Welcome students to lecture number 12 on fuzzy sets, arithmetic and logic. In the last lecture, we started discussing on linear approximation of fuzzy numbers. In particular, we looked at two unary functions namely A inverse and e to the power A, where A is a fuzzy number. The key to the solution is to compute the divergence between the functional value and the linear approximation. Today, we shall see a function with two variables. There are many such functions like say multiplication, division, etc. I shall look at multiplication. So, let A is equal to A1, A2, A3 and B is equal to B1, B2, B3 be two triangular fuzzy numbers. We have seen how they can be multiplied and membership function of A star B of x can be computed. In particular, when A is equal to -1, 1, 3 and B is equal to 1, 3, 5, we found that alpha cut of A star B is equal to the interval -4 alpha square plus 12 alpha -5 to 4 alpha square -16 alpha plus 15 when 0 less than alpha less than half, and this is equal to, so I can write it in a bracket 4 alpha square minus 1 to 4 alpha square minus 16 alpha plus 15 for alpha greater than equal to half. So, these results we already have. Because these are quadratic, we like to use a linear membership function to represent A star B. So, to approximate it, with a linear function, we do the following. So, alpha cutoff, so A is equal to A1, A2, A3, B is equal to B1, B2, B3. Let alpha cutoff A is equal to x alpha comma y alpha, and alpha cutoff B is equal to u alpha comma v alpha. Therefore, alpha cutoff A star alpha cutoff B through interval arithmetic will be minimum of x alpha u alpha, x alpha v alpha, y alpha u alpha and y alpha v alpha to maximum of these 4 quantities. So, that is what we get by multiplying alpha cutoff A and alpha cutoff B. Now, alpha cutoff A star alpha cutoff B when alpha is equal to 0 is A1 comma A3 multiplied by B1 comma B3. Therefore, depending on the sign of A1, A3, B1, B3, we can get the interval, which will be the support for S star B. Similarly, putting alpha is equal to 1, we have alpha cutoff A is equal to singleton A2 and alpha cutoff B is equal to singleton B2. Therefore, alpha cutoff A star alpha cutoff B is equal to the singleton A2 B2. From these two values, we can get an approximation for A star B as follows. So, consider A is equal to minus 1, 1, 3, B is equal to 1, 3, 5. Therefore, 0 cut of A, that means alpha cut with alpha is equal to 0 is the interval minus 1, 3, and 0 cut of B is equal to 1, 5, and 1 cut of A is equal to singleton 1 and 1 cut of B is equal to singleton 3. So, together we can see a logical approximation to A star B is TFN P, which is equal to. Now, if we look at this, we can see that the range goes, or the support of A star B is from minus 5 to 15, and from these two we can get the modal point is 3. So, together we can see the logical approximation for P is minus 5, 3, 15. Question is, how good or bad is this approximation? So, to compute that, we need to check the divergence, that is the maximum difference between the actual A star B and the approximation P. We already know from lecture 10 that the alpha cut for A star B is minus 4 alpha square plus 12 alpha minus 5 to 4 alpha square minus 16 alpha plus 15 when alpha is less than half, and it is 4 alpha square minus 1 and 4 alpha square minus 16 alpha plus 15 when alpha greater than equal to half. Since P is minus 5, 3, 15, alpha cut of P is minus 5, plus 8 alpha to 15 minus 12 alpha. This we know, we have seen many times how to calculate from a given triangular fuzzy number by using the similarity of triangles. Therefore, the difference in the alpha cut on the left hand side is minus 4 alpha square plus 12 alpha minus 5 minus 5 plus 8 alpha if 0 less than equal to alpha less than half, and 4 alpha square minus 1 minus 5 plus 8 alpha when alpha less than equal to half less than equal to 1 is equal to minus 4 alpha square plus 4 alpha when 0 less than equal to alpha less than half, and it is 4 alpha square minus 8 alpha plus 4 when half less than equal to alpha less than equal to 1. So, if we plot the graph, we get at alpha is equal to 0, this is 0, at alpha is equal to half, this is minus 1 plus 2, which is 1, and at alpha is equal to half, this one is 1 plus 4 minus 4 is equal to 1, and at alpha is equal to 1, this is 4 minus 8 plus 4 is equal to 0. So, this is an increasing function, here it is a decreasing function, and therefore, the maximum divergence that we get is at the point half, which is 1. In a similar way, the divergence on the right hand side is 4 alpha square minus 16 alpha plus 15 minus 15 minus 12 alpha is equal to 4 alpha square minus 4 alpha for 0 less than equal to alpha less than equal to 1. So, if we plot this graph for different values of alpha, we get alpha is equal to 0, alpha is equal to half, alpha is equal to 1. So, 4 alpha square minus 4 alpha at 0 is equal to 0, at half it is 1 minus 2 that is minus 1, and at 1 it is 4 minus 4 equal to 0. Therefore, the maximum absolute difference is coming at this point is modulus of minus 1 is equal to 1. Therefore, for both left hand side function of mu a star b and right hand side function of mu a star b, we get the maximum divergence or maximum absolute divergence is 1, and the support of A star B is from minus 5 to 15. So, if we plot it, we get something like this. Minus 5, minus 3, minus 1, 0, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we had this shape. So, this is mu A star B, and the linear approximation was something like this. So, this is the amount of divergence where the maximum is coming to be 1 on both sides. Since the overall difference between the linear approximation and the actual curve is small in comparison with the total support of the fuzzy number, we can approximate A star B with P. In practical applications, one has to make a policy. What is the maximum allowable divergence for a given fuzzy number? That is very important, because as we keep on combining different fuzzy values to in our application, more and more error will be accumulated, as when we are combining different fuzzy numbers with different operators. So, one has to make a policy beforehand, and depending upon the application, one can choose to be the threshold, so that if the difference or the divergence is within that threshold, one can approximate the function with a linear function as indicated in this talk. So, for other fuzzy functions involving two fuzzy numbers may be worked out in a very similar way. Let me now change the topic to linear ordering of fuzzy numbers for any two real numbers distinct real numbers, we have either x is less than y or y is less than x. Since there is a strict order between any two real numbers. This same is not applicable for two fuzzy numbers. For example, -3, 5, 8 and -4, 5, 9. How to order these two fuzzy numbers? It is difficult because on the left hand side this is smaller, on the right hand side, but this is larger. So, it has a much bigger support compared to this, and both of them have the same modal value. So, it is very difficult to order them as such. For reals, there are many different algorithms for sorting them or putting them in a linear order. Those who are familiar with computer programming might have heard of bubble sort, merge sort, quick sort, etc. for ordering a set of reals. Question is, how to order a set of fuzzy numbers? So, I give you an algorithm from the book of Kaufman and M. Gupta. The basic concept is the concept of removal. So, if k is a real number and a is a fuzzy number, then removal on left hand side of a and k is area bounded by the line x is equal to k and Lx of a. In a similar way, R of a and k is the area bounded by the line x is equal to k and R x, the right hand side of the membership for A. For illustration, suppose this is the line when k is x is equal to 0, that is I am taking k is equal to 0, and suppose this is the fuzzy number, then this area is R L A comma 0. Similar way, this entire area this is R R of A comma 0. Removal A comma k is defined as half of R L A comma k plus R R A comma k. For illustration, consider a TFN A1, A2, A3 such that all A1, A2, A3 are greater than 0. Then with respect to k is equal to 0, we have A1, A2, A3. Therefore, R L A comma 0 is this area which is this rectangle whose length is A1, and this area which is the area of this triangle where this length is A2 minus A1 and this length is 1. Therefore, R L A comma 0 is A1 plus half of A2 minus A1 is equal to half of A1 plus half of A2. Now, R A comma 0 is equal to this entire area, as I have explained before. So, this is equal to the same area plus area of this triangle, which is equal to half of A1 plus half of A2 plus half of A3 minus A1 multiplied by 1, which is the altitude, which is 1, is equal to half of A2 plus half of A3, because this gets cancelled. Therefore, removal of A comma 0 is equal to half of A1 plus half of A2 plus half of A2 plus half of A3 divided by 2 is equal to A1 plus 2A2 plus A3 by 4. So, this is the quantity that one calculates first to group the set of fuzzy numbers you want to sort into some equivalent numbers. All those triangular fuzzy numbers for which this quantity is same can be put into the same group. So, let me take an example. Consider A1 is equal to minus 3, 5, 11. Its R is minus 3 plus 10 plus 11 upon 4, which is equal to 4.5. A2 is equal to minus 5, 10, 11, and therefore, R is equal to 20 plus 11, 31, minus 5 is equal to 26 upon 4 is equal to 6.5. Let A3 be minus 3, 5, 6, and you can calculate 10 plus 16, 10 plus 6 is equal to 16 minus 3 is equal to 13. Therefore, R is equal to 3.25. A4 is equal to minus 2, 6, 8, and one can calculate that R is equal to 4.5. A5 is equal to 0, 7, 12. Therefore, R is equal to 6.5, and A6 is equal to minus 1, 6, 7, and R is equal to 4.5. Therefore, on the basis of removal, we have the following. A3 is the smallest, which is less than the set A1, A4 and A6, which are less than A2 and A5. So, we got some partial order, although we find these are tied at the same place because of the same value of removal. Therefore, in step 2, we use the mode of the numbers. What is the mode? The mode is the point where the fuzzy number gets the highest membership value. So, if we compare, the mode for A1 is 5, for A4 is 6, and for A6 is 6. So, mode A4 is 5, sorry, A1 is 5, A4 is 6, and A6 is 6, and mode for A2 is 10 and mode for A5 is 7. Mode for A2 is equal to 10 and mode for A5 is equal to 7. Therefore, at this stage we have the order A3 is less than A1 less than this set A4 and A6 which is less than A5 which is less than A2. Therefore, we could impose an order with these two steps, but still we have a tie between A4 and A6. To break this tie, we use the support. A4 is equal to -2, 6, 8 and A6 is equal to -1, 6, 7. Therefore, support is 10. Here the support is equal to 8 and therefore, we can write A6 is less than A4. Therefore, final ordering is A3 less than A1 less than A6 less than A4 less than A5 less than A2. Question is, can there still be any tie? Answer is no. Suppose A1, A2, A3 and B1, B2, B3 have same mode and same support, then these are the same numbers. Or in other words, two TFNs have the same mode and same support, they are actually the same number. Question is, can two numbers A is equal to A1, A2, A3, B is equal to B1, B2, B3 have the same removal, mode and support? The answer is no. Proof: since they have the same removal, therefore, A1 plus 2A2 plus A3 is equal to B1 plus 2B2 plus B3. Same mode, therefore, A2 is equal to B 2, same support. Therefore, A 3 minus A 1 is equal to B 3 minus B 1. Now, from these we get A 1 plus A 3 is equal to B 1 plus B 3, and from here we get A 3 minus A 1 is equal to B 3 minus B 1. Therefore, we can see by adding 2 A 3 is equal to 2 B 3, or A 3 is equal to B 3, and similarly we can show A 1 is equal to B 1. Therefore, A 1 is equal to B 1, A 2 is equal to B 2, A 3 is equal to B 3. Therefore, these two fuzzy TFNs are same. Let me now introduce you to two more functions which are called mean and max of two fuzzy numbers. Let A and B be two fuzzy TFNs or triangular fuzzy numbers. Let alpha cut of A is equal to x alpha comma y alpha, and alpha cut of beta is equal to u alpha comma v alpha. Then by definition, if C is equal to mean of A comma B, then alpha cut of C is equal to minimum of x alpha comma u alpha to minimum of y alpha comma v alpha. And if D is equal to max of A comma B, then alpha cut of D is equal to maximum of x alpha comma u alpha and maximum of y alpha comma v alpha. For example, consider A is equal to -2, 1, 4. Therefore, alpha cut of A is equal to -2 plus 3 alpha comma 4 minus 3 alpha, and B is equal to 1, 2, 3. Therefore, alpha cut of B is equal to 1 plus alpha comma 3 minus alpha. Therefore, alpha cut of C, where C is equal to mean of A comma B, is equal to minimum of minus 2 plus 3 alpha and 1 plus alpha, and minimum of 4 minus 3 alpha and 3 minus alpha. Now, consider minus 2 plus 3 alpha and 1 plus alpha. Therefore, they intersect at x naught, at alpha naught implies minus 2 plus 3 alpha naught is equal to 1 plus alpha naught, implies 2 alpha naught is equal to 3, implies alpha naught is equal to 3 by 2. Since 0 less than equal to alpha less than equal to 1, therefore, in this range minus 2 plus 3 alpha and 1 plus alpha do not intersect. Therefore, minus 2 plus 3 alpha is always less than 1 plus alpha in 0, 1. On the other hand, consider 4 minus 3 alpha and 3 minus alpha. If they intersect at alpha naught, then 4 minus 3 alpha naught is equal to 3 minus alpha naught, implies 2 alpha naught is equal to 1, implies alpha naught is equal to half. Therefore, alpha cut of C we can write as minus 2 plus 3 alpha to 3 minus alpha if 0 less than alpha less than half and is equal to minus 2 plus 3 alpha comma 4 minus 3 alpha if half less than alpha less than equal to 1. So, let me plot it. A is equal to minus 2, 1, 4. So, this is A, B is equal to 1, 2, 3. So, this is B, and we have alpha C is equal to minus 2 plus alpha till the midpoint. So, this is going to be for C, and for this interval we get this is minimum up to this point, and after this, this is minimum. So, this line is the membership function for C. Note that mean of A B is not equal to mean of A B, which is the standard intersection. In a similar way, one can compute the max I leave it for you as an exercise. Okay, student, I stop here now. In the last few lectures, we have done different problems of fuzzy arithmetic. From the next class, I will start more about fuzzy sets. In particular, I will look at certain properties, and also we will look at extension principle and decomposition theorem, etc., in the next few classes. Thank you.